All right, guys, so if you still have cell phones out, can those be put away, please? Daniel, you also just need to get in uniform. This is going to be our last lesson of Unit 1. We're going to talk about how quadratics and linear functions can intersect. So in grade 10, you guys solved linear systems. You guys remember that? That was like one of your first, or no, sorry, was that grade 9? No, it was grade 10. One of your first units in grade 10 was about like using substitution and elimination to solve with lines. So does anybody remember the possibilities? Like what are the outcomes when we're looking at systems of lines? What can happen when I have two lines on one graph? Zion? Okay. There's actually three scenarios. So they can be parallel, which means what about the point of intersections? Okay, so we could have two parallel lines that have no solutions, right? They don't intersect at all. Now, there's two other possibilities for what we could get.
There's one solution.
One solution, yep. Yep, so one line crosses over the other line and you have one point of intersection or one solution, right? What is the last possibility here? Ivana?
There's just one line.
Okay. So essentially those lines are the same line, right? So they're kind of like overlapping one another and you have infinite points of intersection, right? Every single point on those lines is a point of intersection. So those were our three possibilities when we're talking about systems of lines or linear systems. Now I want you and your partner to think up what the possibilities might be if I have a quadratic and a line on the same graph. So what are the different points of intersections that you might be able to get? Also keep in mind that lines and quadratics continue forever. So if you're drawing pictures of what's happening, you need to imagine that those things are continuing forever before you make a conclusion about that. Okay, so see if you can find, you and your partner can find some options for how a linear and quadratic system could intersect. I'm going to give you a couple minutes to discuss. Okay, somebody give me one. Somebody give me one. Karen.
They don't touch?
Okay. Grade 11s and 10s. Let's focus in here. Okay. What would that look like if they don't touch?
A U and then a line that doesn't touch.
So tell me how to draw it. U facing up?
Yeah.
Like this? And where would I have to draw my line for this to have 0 points of intersection?
Just over that way more.
But it widens forever. Keep that in mind, right? Oh, okay. So maybe like a horizontal line or a line that's kind of like going like this, right? So one of the possible scenarios is that we have 0 points of intersection, kind of like how we had parallel lines, but in this case we just have like a quadratic and then a line that's not going to cross over that. Okay, what else could we have here? Sam? Okay, so what would I draw? Sure. Yeah, and this is probably the most common scenario is that we would have just like a quadratic and then a line that crosses through that. So there's our 2 points of intersection there. So this system has 2 points of intersection. Sorry. Okay, and I said that there were 3. So what is the last one? Zion. Okay, and what would the picture look like for that? Okay. So I would have maybe like my quadratic like this. It could be opening down, and then maybe I just have like a vertical line straight through that. Okay, and then this is the solution to my system right there where that crosses. So 1 point of intersection. There's also a second scenario to something like this where we have 1 point of intersection, and it is what we call a tangent line. So it's kind of similar. It still is going to have 1 point of intersection, but what we might have is like a quadratic and then a line that skims our function just at 1 point. So in that scenario, that was not a good line. Okay, so it actually just like skims over your function, at exactly one point, and this is what we call a tangent line. So it also has one point of intersection, but when it skims the function like that, we call that a tangent line. Okay, and that could be another possibility that we would have for one point of intersection there. Okay, that's all we can really have. We can't actually have, in a situation like this, we can't have infinite points of intersection because those functions are two different functions. They can't overlap infinitely like this system of lines would. Okay, so I'm going to kind of show you guys the steps of how we would solve something like this, but it's very similar to how you would solve a quadratic regularly. There's just kind of like a couple extra intro steps that you have to do. So let's do steps real quick here. So I'm going to be presented with a line and a quadratic, so the functions of those two things. And what I'm going to do is set the equation of the line equal to the equation of the quadratic, just to start. Oops. Okay. So what we're going to have then is kind of like an mx plus b equal to an ax squared plus bx plus c type equation. And anytime I'm solving a quadratic, I usually want it set equal to 0 on one side when I'm solving something like that. So what we actually need to do for the next step is move all terms to one side. Usually I move the terms in the line just because there are less of them. But we're going to move all terms to one side so that we have the other side set equal to 0. So the other side is equal to 0. Okay, and then the last step is basically going to be obviously to simplify all those terms on one side. So we're going to simplify like terms. And once we have that, what you're going to have will look exactly like a quadratic. So how do I solve a quadratic? What are my ways that I can find the solutions to a quadratic? Carla?
Quadratic formula.
Okay, so one option is quadratic formula. Usually that's what we go to if the first option doesn't work. So what's the first option? Ivana? Factor, okay? So we're going to solve the resulting quadratic. And what we would like to do, just because it's faster, is first check to see if we can factor. If that doesn't work, then we go quadratic formula. Okay? So we solve, the first thing we check is, can I factor? That would be first. And if the answer is no, then I go to quadratic formula. Now, it's important for us to know that we are not solving for x-intercepts here. We're actually solving for the points of intersection, right? So when I solve for the x's, whether that be through factoring or through the quadratic formula, the y-coordinates to those points will not be equal to 0. So once I find my x or x's, how do I get the y's of these points? Ivana? Right. So we'll get the x's from this. We must sub those x's back into one of the original equations to get the y coordinates. Okay, so that would be the last part. And it should be the same. So if I get that x equals 1 and 3, I should get the same y coordinate if I plug it into the original line or the original quadratic, because it's the point where they both have the same x and y coordinate. So if I plug it into the line and also into the quadratic and I don't get the same y, I've probably done something wrong. Okay, so that's a good way to check your work. So we're going to plug the x's back into one of the original equations. And then we should have our points. Okay, or sometimes if there's no points of intersection, we won't have to do really any of this. Yeah. So far, so good? Okay, let's see if we can apply these. Okay, so the first little part is actually not part of our steps that I listed above, but it requires us to do the first two steps. So just like we can check if a quadratic has 0 x-intercepts, 1 x-intercept, or 2, I can actually use the discriminant to check how many times these things intersect. But I have to do the first couple steps first. So my very first step that I listed above is to set the equation of the line equal to the equation of the quadratic. So I'm going to set this equal to this equation, because I'm trying to find where the x's and y's are equal for both of these. They both have the same value. So step number 1, set them equal to one another. Okay, that's step 1. Yep.
So x squared minus 7x minus 50 is the equation of the quadratic.
Yep.
And then the other one is essentially the equation of the line.
Yep. So w at x is your quadratic, f at x is your line.
Okay.
Yep. Okay, second step, we want to move everything to one side, so we have 0 on one side. So I'm just going to move the 2x over and the -5. Remember to switch their signs when you do that. And then we want to simplify. I'm just trying to group the things that are x's and group the things that are constants just to save myself some work, but it doesn't really matter the order in which you put those. Okay, at this point here, what I have now just looks like a regular quadratic, right? We know that it's not. We know that it's the equations of both of those things together, but this is how we're going to solve it. But I can actually first, before I try and go to solve this whole thing, it would be nice if I could predict. That way, if I have 0 points of intersection, I don't have to do more work than I need to. So I can actually do a quick prediction right here to see how many points of intersection I should expect to get from this question. And we're actually just going to use b squared minus 4ac. Okay, so I think we get 81 plus 40, so 121. Yeah, that makes sense. Okay, so when we were predicting with the discriminant and just talking about roots, if we had a positive value from our discriminant, it meant we had 2 roots. Now, any guesses as to what this means as far as number of points of intersection? Karen? 2, okay? When it's positive, it means 2. If it's equal to 0, it means 1. And if it's negative, it means none. So same kind of idea that we use when we predict roots. So this is positive. Therefore, we have 2 POIs. Okay, so that's part A. Part B, I'm going to work from this equation right here. My job is to solve this equation to get the x's and then sub back in to get their matching y's. So my first thing that I would check here, just because the a value is 1 here, it would be really easy if I can happen to find 2 things that will help me factor this. I would like to be able to factor that. Okay, so are there any 2 things that multiply to -10 and add to -9? Sebastian? Awesome. And because the a value is 1 here, I can actually just sub these right in and factor, right? So Luca, you look confused. Can I clarify anything for you? You okay? You sure? So far, so good. Any questions? Okay. So that was step number 5. We want to solve that quadratic. I think it was 5. Or no, was it 4? 4? Just double check. 4. Because this was positive. So I'm looking to see whether that discriminant is positive, 0, or negative. If it's positive, 2. If it's 0, we have 1. If it's negative, we have none. Okay, so this is step 4, sorry. Okay, now I need to get my y coordinates of my point of intersection. So my job is to sub these back in, not to this equation that I set equal, but to one of the original 2 in my question. Now you can sub it into both if you want. You should get the same y coordinate out of there. Usually I just choose to sub it into the line because the line is quicker to calculate. So I'm going to sub it into f at x equals 2x minus 5 to get my y's. And I have to do that for each one of these. So I'm going to evaluate f at 10. So I'll do 2 times 10 minus 5, and I will get 15. So my first POI, or point of intersection, is 10, 15. That's where the line crosses the quadratic. Okay, and then I'm also going to evaluate f at negative 1. And I will get negative 7. So my second POI, or point of intersection, is negative 1, negative 7. So those are the solutions to our linear quadratic system. Any questions on this one? Okay, this was the last step. This was step number 5 right here. Any questions? Okay, you and your partner are going to try the next one. Okay, example number 2, and then I'm going to show you one that's slightly different. Okay, so see what you can do with number 2. You're first going to make a prediction with the discriminant, and then you're going to find the point of intersection if necessary. I'll be there in 1 second. Okay, I'm going to put my first couple steps up here, and you guys can check your work as you go. Okay, first part's up. You guys are going to see if you can now find that point of intersection. Okay, guys, just a little hint. This can be a lot easier to solve if we actually go through this quadratic. Oh, is my thing frozen here, maybe? If we go through our quadratic here and we actually just multiply it to get rid of that denominator. So what I might do, just to make my life easier, is get rid of this 2 by coming through and multiplying everything by that denominator. Pardon? Oh, that's why it's not working, because I had it frozen. Okay, so I'm going to come through and multiply each term by 2, and what this does for me is it allows me to get rid of this 2 in the denominator, and then possibly what I can do is actually factor this quadratic instead of using quadratic formula. So what I get here is now, I'll just write it down here, 0 equals, the 2's cancel, and I'm left with x squared minus 4x plus 4. Okay, so that is much easier to factor than this guy, or even easier to plug into the quadratic formula if I need to.
Wait, isn't it supposed to be negative now? So bring it over?
I'm not bringing it over, I'm just multiplying every term in the equation by 2.
No, like the first step. When you let go up.
I'm moving everything left, not right. Or sorry, I'm moving everything right, not left.
Yeah, then should be the middle should be 2. It's just 2, not negative 2. Because originally it wasn't negative 4.
It was 2 and
Yeah,
negative
because
4.
it's not negative 4.
Positive.
Yeah, and then I brought it over to this side, so it became negative,
Yeah.
right?
Oh, I did. Yeah. Okay.
Yeah. Carlo, question?
For that part, we're simplifying.
Yeah.
You're just, for the 2's, I'm sorry, I'm confused.
So when I have a fraction like this,
No, I know.
I'm getting rid of that fraction by multiplying every term in the equation by the denominator so that it cancels out.
Yeah.
Okay? It's still an equivalent equation as long as I do that to every single term. It just makes it a little bit easier to work with.
Yeah.
Luca?
But we don't have to do that, right?
You don't have to, but your life will be much harder if you don't. So we like to make our life easier, right? So, Paige.
Why does it equaling 0 mean there's 1 point?
The discriminant?
Yeah.
So if you think back to kind of our grade 10 stuff and the review that we did earlier, when the discriminant is positive, it tells us we have 2 roots for a quadratic usually. When it's equal to 0, the part in the quadratic formula will that second part, when we do plus 0 and minus 0, that is still the same, right? So we actually just end up with 1x from that when we get 0 for the discriminant,
So
if that makes sense.
It's 1, if it's more than 0, then
It's 2.
and if it's a negative, then it's
None. Yeah, you got it. Okay, so this should be pretty easy for us to factor here, right? We get x minus 2 times x minus 2 when we find 2 things that multiply to 4 and add to negative 4. Okay? This is also a perfect square trinomial, if you notice that. And we can kind of see that because we end up with x minus 2 squared here. So what is my x equal to? X equals 2. And then I need to get the y. That's my job, is to get that y coordinate. So the y coordinate, sorry, I'm going to get these squigglies out of here. The y coordinate, I can either sub into g at x or I can sub into f at x. I think g at x is a little bit easier. So we're just going to evaluate g at 2. Ooh, sorry. And was it minus 10 or plus 10? Minus 10. Okay, so our point of intersection is 2, negative 2. And we expected to get 1 only, and that makes sense that we only got 1 here, right? Okay, so this is the last step. This is step number 5 here, just solving for that point of intersection, the y coordinates. Paige?
I'm kind of confused. How did you get 0 equals x squared minus 4x plus 4?
So when we had 0 equals half x squared minus 2x plus 2, you're good up to that point? Because we were just like simplifying,
Yeah.
right? Okay, so the deal is when I have an equation, I'm going to rewrite it out here quickly. okay? When I have, oh, sorry, it was plus 2. When I have an equation like this is actually much harder to solve than just a regular quadratic, right? Because it has a fraction in it. But I can make an equivalent equation by multiplying every term in this equation by the same value. So the idea is that we went through and multiplied every term by this denominator right here so that we could get rid of that denominator. So I went through and I multiplied every term by 2, like so, times 2, times 2. And then what happened was these actually get to cancel, and I'm just left with x squared there. So I get 0 times, or equals x squared, and then the 2 times 2 equals 4x, and the 2 times 2 here equals 4. Okay? So it's equivalent because I did it to every term, but it's just easier to work with now. Okay? Yep. Any other questions on this one? Okay, the last question is a little bit different. It refers to that tangent line thing that I was telling you about earlier. So it's important for us to remember when we see the word tangent line, we want to think one point of intersection. Is it okay if I scroll from this? Is everyone good?
Sure.
Okay.
Just 1 second.
Oh, yep, sorry.
Sorry, one more. Just ask like
Yep.
first question. You predicted it.
Yep.
You predicted you used a fraction, sorry?
Yeah, I was just using the original equation. You could predict using this new one too if you want to. So you should get the same answer either way because it's an equivalent equation.
All right.
Okay?
Yeah.
Okay. So, all right, so in these types of questions, you might see one point of intersection or you might see the word tangent line. You should kind of think about these in the same way. So if you see one point of intersection or you see tangent line, same thing. So we have a line with a slope of 4. So I'm going to call the line g at x for now. Okay? This is what we know about the line. We have a 4x plus a b, some kind of b. So I'm using the equation mx plus b. So all I know right now is that that's what we have, slope of 4. I also know that it intersects once with my quadratic. So maybe it's a tangent or maybe it cuts through the middle vertically or whatever. Alex? Because this tells me I have a line. So this is like my mx plus b for my line. And it tells me I have a slope of 4. So I'm just plugging in the m for the mx plus b. Good? Okay. So it has one point of intersection. What does that tell me about b squared minus 4ac? Zion. It equals 0. This is key in order to solve this question. Okay? Super important. So we want to know what is the y-intercept of the line. So this is the goal. I want to find that value. And I'm going to use this idea to help me, this b squared minus 4ac. Now, because we already have a b squared in here, maybe we could make this b equal to a different variable just for kind of keeping things straight. So something maybe other than a, b, or c. Marissa, can you choose something for us? Maybe not m, because we have mx plus b. J, that works, sure. You choose m for Marissa. Okay, so we're going to let it be j just for now because we already have b's in the discriminant and that could get confusing. Okay, so I'm going to follow the first couple steps. I need to still combine that line and quadratic, so I'm going to still set them equal to one another and just work as usual, keeping in mind that this value right here is a constant value. What do I mean by constant? No. When I say constant, it's just like a number by itself, right? It doesn't have any x's attached to it. So that j is representing some kind of number. Okay, so just keep that in your mind. Okay, so we're going to set the line equal to the quadratic as usual. We're going to use j as our value there. Okay, and then we're going to move things as usual over to the one side here. And because j is a constant, I'm going to kind of group it in with the -8 here. Now I obviously can't combine those things because I don't know what value j is right now, but I can combine these. And I want to think about this whole value right here as my c value. Okay, this is the b value, we know that, and this is the a value. So far, so good? Any questions? Okay, now this one should be pretty straightforward from here on out. You guys already told me that in the discriminant, I know b squared minus 4ac equals 0, right? So now all I need to do is just sub in my a, b, and c and just solve for j. That will be the only unknown once I sub in. So b is -2, a is 1/2, and c is -8 minus j. Now we're just going to simplify and solve for j. Okay, so before anybody asks me where this -2 came from, 4 times 1/2, 1/2 of 4 is 2, right? So I'm just putting these two things together to get that -2 there. Okay, we're going to bring the -2 in so that we can start to get j moving around here. So positive 16 and positive 2j. And now my job is just to isolate. So I'm just going to move the 20 over, and it will become -20. And then I just have to divide that 2 out there on both sides. Okay. So we get j equals -10. That is the b value in my y equals mx plus b. So the equation of the line, if it asks you for the final equation of the line, it would be 4x minus 10. Okay? This is actually the example that we just did, but in the opposite way, right? You solve for a constant instead of the point of intersection. Isabella.
Why don't you make the 2 negative when you're going to the other side of the equation?
Why wouldn't I? So when I only do that if I'm like adding or subtracting a term. When I'm dividing, I don't need to change the sign of the term.
Or multiplying?
Yes, exactly. Yep.
Would you scroll up for a second?
Yep. Is that far enough?
Just like all the way.
Okay. Any other questions on this one? Okay, so we're still doing the first 3 steps. So we're still setting equal, moving all terms to one side, and simplifying. And then you need to use the information about the one point of intersection to solve in the discriminant. Cool? Okay, good.